Welcome to CEC Gurukul Lectures. I am Dr. Sangeeta Kaul from Department of Chemistry, Sri Aurobindo College, University of Delhi. And today we are starting a new series on green chemistry. This is the first lecture in the series and the topic is Green Chemistry, the Way Forward. Green chemistry is a new upcoming field of chemistry. This field has the capability to make the quality of life better for mankind across the globe. And by the end of this talk, it will be clear that green chemistry can keep us healthy and increase our life expectancy. At the same time, environment is not harmed. Also that green chemistry is a specialized discipline that advocates for more intelligent and sensitive production processes in industries, especially those processes that make extensive use of chemicals. In the present day scenario, requirement of mankind across the globe is adequate food and effective drugs. But unfortunately, in attaining the above, global environment and subsequently the ecosystem as a whole gets affected. Hazardous chemicals which are harmful for environment and for health of human population, it enters soil or water or even atmosphere. So keeping this in mind, we'll discuss the following topics. The topics that we are going to cover in this lecture are why green chemistry is needed, what is the importance of green chemistry, then we'll move on to the 12 basic principles of green chemistry, then limitations of implementation of green chemistry and green chemistry in daily life. We know that chemistry improves the quality of life and chemical reactions and chemists are involved in various fields of like dyes, fuels, effective drugs and pharmaceutical industries, then preservatives, fertilizers, polymers and fungicides, pesticides, etc. So chemical industries are the backbones for development of nation. And these provide not only employment opportunity but also increased income and provide better living standards. So chemical reactions are involved in production of common products which we use in everyday life. So many of these products like dyes or fuels, these are all used in our everyday life. Pharmaceutical industry, it provides not only antibiotics or maybe vaccines but also medicines for day-to-day activities like acne, burn, removing scars, etc. Polymers, again, they are involved in big way in packaging industry, then toys, leisure items, to just name a few. They are also, we can say that polymers are involved in furnitures, adhesives, transportation industry. Then if we speak about preservatives, preservatives not only enhance the shelf life, but they also maintain freshness of food items and also help in fighting the spoilage caused by bacteria, molds, yeast, etc. So the goals of green chemistry are to maximize the safety of chemical and products and minimize the production of hazardous waste and to reduce the amount of non-renewable sources required for the chemical production. This is the reason that green chemistry is called sustainable chemistry. We have to control the input and the use of chemicals in the environment, and that has to be the main objective of the sustainable development. This is the reason why lot of research effort relevant to green chemistry is focused on chemical manufacturing processes. So green chemistry is totally aimed at development of new clean processes. Now we know that chemistry, though useful, is the cause of number of environmental problems. So we'll talk about certain chemicals which have detrimental effect on the environment, and we'll also talk of some of the disasters, the industrial disasters which have happened because of the chemicals. So this will tell us that why we need green chemistry and how to contain the detrimental effects. So to begin with, we'll talk about the most talked about hazardous chemical, and that is chlorofluorocarbon. Chlorofluorocarbons, as we know, that these are the organic compounds and they are made of carbon, chlorine and fluorine. And these chlorofluorocarbons, they are present in the these chlorofluorocarbons, they can destroy the ozone layer. This ozone layer, it is present in the stratospheric layer of the atmosphere. So chlorofluorocarbons, now they find a variety of usage. They are used in refrigeration industry, they are used in solvent in electronic industry, they are used as propellant in solvents, and they destroy the ozone layer that is present in the stratospheric layer, as I said earlier. Now what is the stratospheric layer? In the atmosphere, the first 10 kilometers from ground is the troposphere. After 10 kilometers to 50 kilometers, that is the layer from 10 kilometers to 50 kilometers is called the stratosphere. After stratosphere comes the mesosphere. Mesosphere is from 50 to almost 85 kilometers. Then comes the thermosphere, that is 85 plus, and exosphere, that is 500 kilometers plus. So as we said that this ozone layer, it is present in the stratospheric layer, that is from 10 kilometers to up to 50 kilometers. And chlorofluorocarbons, they destroy this stratospheric layer. So what happens that the layer, this ozone layer, it absorbs harmful UV radiations from sun, so that it does not reach us, and in its absence, in the absence of ozone layer, it will reach us and cause skin cancer and other harmful diseases. So awareness is a must about this. The CFC, this has a lifetime in the atmosphere of about 20 to 100 years, and consequently one free chlorine atom from CFC molecule can do a lot of damage in destroying this ozone molecule for a long time. And so we have to come up with greener alternatives. We can like natural refrigerants like water or maybe carbon dioxide and ammonia, etc. You all must have observed that nowadays the refrigerated solutions, or maybe some aerosols, they come with a message written that these do not contain CFC. So they are better suited for the environment. Next, after CFC, we move on to some of the pesticides. Pesticides, we know they can be of three types. They can be fungicides, herbicides or insecticides. Now, one of the most commonly talked about pesticide is DDT. This DDT causes pollution of crop. It enters the crop, it enters land, and finally it enters the food chain. It gets accumulated in the tissues of animals, causing number of diseases. But at the same time, this is essential for increasing the yield of crops, and but it is a health and an environment hazard. Now, there's a finding by WHO that almost 750,000 people are poisoned every year due to the pesticides, and this results in an average almost 14,000 deaths. But we cannot do without pesticides also, but it is just that the pesticides have to be chosen intelligently. Of course, they should have a broad spectrum to reduce or eliminate pests, but at the same time, these pesticides, they should be non-toxic to plants and animals, and they should be non-toxic to beneficial insects like some of the earthworms which are present in the soil. Not to mention and not to forget that they should be cheap. The residue persistence should be optimal. Then we'll talk about the next hazardous chemical, that is dioxin. These dioxins, they are produced by burning of garbage, medical waste, toxic chemicals, etc., or we can say by burning of chlorinated compounds. Also produced by bleaching of paper with chlorinated compounds. Dioxins are also produced by in the manufacture process of PVC and other chlorinated pesticides. Now, this is one of the most dangerous synthetic carcinogenic chemical, because these are fat soluble and they bioaccumulate in the body and hence they enter the food chain. During 1970 Vietnam War, US military had sprayed almost 42 million liters of herbicide known as Agent Orange. This Agent Orange was a mixture of 2,4-dichlorophenoxyacetic acid and 2,4,5-trichlorophenoxyacetic acid. This herbicide, that is Agent Orange, was used to destroy the forest cover, because the communist forces of the Vietnam, they were hiding in the forest, and the US military was using this as a spray to destroy the forest cover so as to spot the communist forces, those they were hiding in the forest cover. Now, this Agent Orange, this was contaminated with dioxin, and this resulted in serious health issues as it got absorbed through skin. The children born to the affected mothers had low IQ, some suffered from skin tumors, some had leukemia, adults reported low levels of testosterone, and these effects, they were long lasting. These dioxins, they were getting absorbed in water, and from water getting on to water planktons, finally to fishes, and getting on to humans. This is how they were entering the food chain. Also, dioxins were getting absorbed in the soil and through crops and cattle grazing on those crops, again entering the human chain, and also through the atmosphere, air, directly getting absorbed by the human skin. Next chemical that we'll talk about is thalidomide. This thalidomide was in use in Europe and mostly in Germany in 1959 to 1962. This was used as an anti-nausea drug for expecting mothers, and it was found that this was resulting in birth defects. What was happening was that this thalidomide, this had two enantiomers, and each stereoisomer had a different effect. Enantiomer A had the desired effect, that is, it could be given to pregnant women and it was acting as a good anti-nauseating drug, but the enantiomer B, this resulted in birth defects, and since both the enantiomers were getting mixed, so this was causing trouble. Had the right knowledge been there that we have to separate the two enantiomer A and enantiomer B, the problem wouldn't have occurred. Next, we move on to methyl isocyanate. Methyl isocyanate, as we all know, MIC, this caused the worst industrial disaster in the world. On December 2nd, 1984, 27 tons of MIC was released from the Union Carbide factory in Bhopal, India. And what happened was, this MIC, this was a byproduct for the production of an insecticide known as carbaryl. Carbaryl is commonly called Sevin, and this Sevin was to be manufactured, or carbaryl was to be manufactured. And in the manufacture process, the equation was that methylamine was reacting with phosgene to produce methyl isocyanate, and this MIC again reacted with alpha naphthol to give us the desired product. Now, methyl isocyanate is always associated with some of the unreacted phosgene, and phosgene is the gas that was used in World War I. So, both the chemicals were highly toxic. What happened that this MIC, it leaked from the tanks in which it was stored, and a cloud was formed by this MIC, and it spread over the whole of Bhopal city and nearby areas, killing approximately 4,000 people within a few days and affecting thousands. Approximately 22,000 people have died so far, and not to mention that these are the official figures. Actual numbers supposedly are much more, and those days it was said that almost one person per hour was dying in the first few weeks. So MIC, this caused irritation in eyes, nose, mouth and pulmonary diseases, and there was utter chaos in the city because of this. So as I have shown here in this equation, that had there been a better procedure for this production of carbaryl, or the chemist would have worked, then this wouldn't have happened. What had happened was that MIC, or for leakage, water had entered the tank where MIC was stored, and none of the 6 safety systems were working. The plant siren was off, the gas scrubber where the gas could be detoxified was also off, and the refrigeration unit which was to be used for cooling the liquid was shut, and this was shut, the sad part is that it was shut just to save money. And there were 3 tanks in which MIC were to be stored. One of the tank was totally empty, the other contained almost 40 tons of this gas, and the third tank had 15 tons. So had this 40 tons been half of it put in the tank which was empty, maybe the disaster wouldn't have happened. And since water entered the tank, exothermic reaction took place and the tank was blown off. So we are talking about some of the industrial disasters in the line. I'll also talk about another disease, that is methylmonoglobinemia. This is caused due to excessive use of nitrogen fertilizers. What happens, the nitrate ions, they get concentrated in leafy vegetables. Nitrates are not harmful, although they get bioaccumulated in bodies, they are not harmful, nitrates. But in body, these nitrates, they get reduced to nitrites. And excess of nitrites in the body is carcinogenic. So excess of nitrates finally leads to blue baby syndrome, also called methylmonoglobinemia, in small children. Nitrates, they get reduced to nitrites, which react with hemoglobin in the blood, and this reduces the oxygen carrying capacity. This is known as blue baby syndrome. So after this, that is this disease is due to excessive fertilizer which are put in the leafy vegetables. Next is Itai disease. This Itai disease, this is caused by cadmium poisoning, and the bones, they become fragile. Kidney problems are associated with this, then anemia, disorder of bone marrow, and even cancer. When excess amount of cadmium ions are ingested, they replace the zinc ions at major enzymatic sites and cause metabolic disorders. There was another disease which is called Minamata disease. Minamata is a coastal town in Japan. It was certainly observed that the birds in that region, they were losing coordination. The cats, they started running in circles. The fishermen were suffering, and the babies born to the fisherwomen there, they had congenital defects. So finally it was found that this was all due to mercury being released by a vinyl chloride factory which was situated near the bay. The microbial action by the microbes, they were changing the inorganic mercury which was being released to organic form, that is, it was getting converted to methyl mercury, and this was getting transported through RBC of the blood and damaging the brain cells. Organic form of mercury was getting absorbed, and it is 100 times faster, the absorption is 100 times faster than inorganic form by water animals. So once it entered the water animals, it immediately entered the food chain and caused harmful effects to humans too. So now, knowing about the various industrial disasters and the harmful effect of the harmful chemicals, we move on to why green chemistry is needed, or what is green chemistry. Green chemistry is the utilization of a set of principles that reduces or eliminates the use or production of hazardous substances in designing, manufacturing and application of chemicals. Green chemistry is a globally accepted term to describe the efforts of the scientific community to develop manufacturing processes which are environmentally friendly. In other words, green chemistry is all about designing safe and sustainable chemical processes. That is, environmental considerations are the integral part and the process has to be environmentally benign. Green chemistry does not aim towards remediation or the cleanup of the pollution, but instead the goal is to create products that by no means will contribute towards pollution at all. That is, this is a very important point, that we do not aim, or the green chemists do not work on removing the pollution, but at the onset of the reaction, we have to take care that no pollution takes place at all. So to do this, there are certain goals which have to be kept in mind before designing a reaction. That is, designing safer chemical entities which are not hazardous to mankind and are equally efficient or better suited. So designing of chemical reaction is the most important thing. Then development of chemicals which are biodegradable and non-bioaccumulative, so that it does not affect the food chain and does not affect our ecosystem at all. Sustainability of natural resources, avoiding petroleum and coal-based products. We know that if we go on using the petroleum and coal-based products at the present rate, then we will not be leaving it for our future generations. So sustainability of natural resources is a must. Efficient energy sources are to be used. That is, we have to go for microwave and ultrasound reactions, use of renewable source of energy, designing reactions such that less hazardous waste is produced, that is preventing pollution at molecular level, continuous innovation to solve the real world problems, reuse and recycling of chemical products and byproducts. In my next lecture, now I'll be dealing with the principles of the green chemistry, how to achieve these goals and so on. Thank you.